So I gave you guys 3 questions. Were you able to do this? Did you try them? Okay, I don't think you tried. Okay, fine. Let us look at the first one, benzene to aniline. So I hope all of you know the structure of benzene and aniline. Yes or no? Tell me.
Yes, sir. Yes, sir.
So we have benzene. And we have to convert this to aniline. In aniline, we have NH2 group that is attached. And the benzene ring. Okay. So for this, is there any way that you know of that we can directly attach NH2? Because we know that benzene gives some electrophilic aromatic substitution, right? You know that it will give you nitration. You know it will give you sulfonation. You know it can give you halogenation. It can give you Friedel-Crafts alkylation and also acylation, right? Yes or no? So whenever you have to do conversions, you have to know what are the reactions that this benzene can give me, how the benzene will act as a reactant, and how is it going to give me reactions. So obviously there is no reaction that we know of that can directly give me NH2 group in the benzene ring. Yes or no? Guys, tell me. Is there anything? Is there anything that can give NH2 group on the benzene ring with one reaction? You guys, know this, na? Electrophilic aromatic substitution? No. Fatima, Amalia, Nazira?
Yes, sir.
You know these, na? There are electrophilic aromatic substitution. Okay. So for benzene, first we will do nitration. That means HNO3, concentrated HNO3 in the presence of concentrated H2SO4. Then I will be getting NO2 group attached in the benzene ring. And yesterday we studied how to convert NO2 into NH2, reduction of nitro groups, right? So we can use any of the reducing agent, H2 in the presence of nickel, PD or PT or anything else, and you'll be converting NO2 into NH2. That's it. Simple 2-step reaction. Have H2, presence of PT or PT, and you will be getting, instead of NO2, this will be converted to NH2. Okay. Next one. This is benzene into Nnn Dimethyl Aniline. So we have to start with benzene again. You have to convert this to Nnn Dimethyl Aniline. That means nitrogen, which is connected to CH3 and one more CH3. One more CH3. It's a simple reaction in which this is the conversion that we have to do. So first step will be to convert benzene to aniline that we just did right now. So in this reaction, we'll be using reagent in the first step, that is HNO3 plus H2SO4. In the second step, we will be using H2PT or PD anything else, and we will be getting NH2. We will be getting NH2. Now, we know a reaction in which we can add R groups. We can add R groups. So if you see this reaction of ammonolysis, now in this you can see, if you have any RNH2 and you treat this with Rx, that means any alkyl halide, then you attach the R group that is present in the alkyl halide. So using this reaction, we can treat this with any CH3 X, X being the halogen. So if I treat this with CH3Br, and this nitrogen is going to attack on this carbon, the bromine will leave, and you will be getting, first of all, CH3. If I treat this again with CH3Br, then again this lone pair is going to attack on the CH3. And we are going to get nitrogen. This is attached to 2-methyl group and a benzene group. Okay.
Sir?
Sorry, I just had to leave. Okay, there was somebody at the door. Tell me. You're saying something?
The third step, can you explain again?
Which step? This one.
The 3. No, the next one.
Again, here we have lone pair, no?
Mm-hmm.
So similarly, this nitrogen will attack on this CH3 as it attacked here.
Okay, sir. Okay.
Same reaction. So if you refer to the ammonolysis reaction, in that we did a series of steps which were very similar. In that we took R group. Okay, yeah. So RNH2. Now this is RX. Okay, this is RX. So any alkyl halide may be there, CH3X or any C2H5. So you can add any alkyl group on the nitrogen atom by just reacting it with alkyl halide. Okay. Yes. So we are done with 2, right? Are you noting this down?
Yes, did noted, sir.
Noted. Okay, fine. Next is C2H4 into hexane 1,6-diamine. Hexane 1,6-diamine. So I think this is Cl CH2 whole 4 Cl to hexane 1,6-diamine. So I have this is my reactant because 1, 2, 3, 4 carbon atoms and there is Cl and Cl, and I have to convert this to hexane. That means 1, 2, 3, 4, 5, 6, and there is an NH2 group here, and there is an NH2 group here. Right. So this has 4 carbon. This has 6 carbon. Right. So what did I say? Whenever you have to increase the number of carbon atom, what reaction do we need to do? What reaction should we do? Yeah, KCN. So when I will react with this, the alkyl halide with 2 moles of KCN, the Cl will be replaced by Cn. So I will get a Cn here, and I will also get a Cn here. This is the new addition here. And now we all know how to. We now have how many carbon? 6 carbon atoms we have. We have 1 nitrogen. We just need to reduce, right? So what are we going to do? We are going to reduce the Cn group to NH2 by using any of the reducing agent. You can just remember H2 in the presence of Pt. H2 in the presence of Pt. So you will be getting hexane 1,2-diamine. or you can use anything else. You can also use nickel. You can also use platinum, palladium, platinum, nickel. And then you use catalytic reduction, and you will be getting NH2 in the planes of Cn. Let me know if you have noted this down. Then we will start today with physical properties of amines.
Yes, I do.
Done. Okay. But start doing questions, okay? Unless you start with a reactant, and then you try looking at the notes, whatever reaction you have done earlier, then try to make some conversions. Then only you will be able to remember the reactions. Otherwise, you will forget it. That means the applications. Questions are important. Okay. So physical properties. Means. So basically, amines, if I talk about the smell, they are quite smelly. They don't have very pleasant smell. They smell bad. And this is, I don't know if this is true or not, but have you heard of this little phrase, yellow, yellow, dirty fellow?
Yes.
You must have heard, right? And I think it has something to do with amines, because amines usually these are they exhibit some kind of yellowish color if they are present somewhere. They kind of exhibit yellowish color, and they smell very bad. They smell very bad. So most of the compounds that you will see of amines, they will, and wherever amine is present, it imparts yellowish color. So I think this phrase yellow, yellow, dirty fellow might have been only because why this color yellow? Because everything that was dirty, it smelled, everything that was dirty and smelled bad was of yellow color. And that yellow color was imparted by amine. And that is why we have this phrase yellow, yellow, dirty fellow. I just think so. I don't know whether it is true or not. Okay. Physical properties of amines. So physical properties of amines, they smell bad. We can say smell unpleasant. They smell unpleasant. And most of them are like slightly, like in the pure form, you will find them colorless, but when they are present like at normal conditions, they will oxidize with oxygen and somewhat impart yellow color. But they smell unpleasant. This is one of the characteristic property of amines. And the lower members, they are gases, but I think after 5 carbon atoms, these amines are liquid. So we'll be mostly talking about its boiling points. So if I talk about its boiling point, the boiling point of amine, then it will be higher than hydrocarbons comparable molecular mass. Why? Due to presence of hydrogen bonding. Due to the presence of hydrogen bonding. So when we have nitrogen, which is attached to at least 2 hydrogen, because we have an R group here, it will be attached to. So basically, the structure is like this. We have nitrogen. You can have another nitrogen like here. It can have hydrogen bonding with this nitrogen. Another nitrogen here, it can also have hydrogen bonding. This can have hydrogen bonding like this. Okay, so there are hydrogen bonding present in amines. Now, as you can see, if you have more number of hydrogen atoms, then there will be more number of hydrogen bonds being formed. So primary amines which have two hydrogens, they will have the highest boiling point, followed by the secondary, and then the lowest will be tertiary. The lowest will be tertiary. Presence of hydrogen bonding. One more point you can write. Tertiary amines don't have any hydrogens attached to nitrogen. Hence, they don't form hydrogen bonds. Hence, they don't form hydrogen bonds. If I compare, so we can say the boiling point order will be: primary amines will have the highest boiling point, followed by secondary, and then at last will be tertiary. Now, talking about the boiling point of amines and comparing it with alcohols and carboxylic acid. So obviously amines will have lower boiling point than alcohols and carboxylic acid. Acids due to lower electronegativity of nitrogen. So how does hydrogen bonding works? Due to lower electronegativity of nitrogen, we have NH. So there will be delta negative, delta positive, right? Now, if the nitrogen is very electronegative, if the electronegativity of the atom that is bonded to hydrogen is very high, this delta negative will be very high, and this delta positive will also be very high, and hence it can form a hydrogen bond which is of good strength, nitrogen and hydrogen. So delta negative and delta positive. So it's basically a electrostatic kind of attraction between hydrogen which is having positive charge and the nitrogen which is having delta negative charge. Now, if I compare this delta positive and delta negative charge in the OH bond, then the OH is what? Oxygen is more electronegative, so this will be more delta negative. If it is pulling more electrons, then hydrogen will be more delta positive, and that is why this bond between OH, the hydrogen bond between O and H, is more stronger than the hydrogen bond in nitrogen. That is why, due to the lower electronegativity of nitrogen, the H bond in amines is less strong than hydrogen bond in alcohols and carboxylic acids. Okay. Is this clear with everyone? Yes or no?
Yes, sir.
Okay. Next is okay. So we have already said about the isomeric amines, about primary, secondary, and tertiary. And what will happen if I branch it? So branching will also decrease the. Branching is going to decrease the boiling point. Decreases. This is a general observation that boiling point decreases as we increase branching. Okay, so let me give you a question. Write this down. Write the question down. Compare the A, B, and C, which is the highest. You have to compare A is greater than B is greater than C, or what is the order? You have to tell me the order, huh? Compare it. Okay, Amalia, can you please turn the mic on? Yes, Amalia.
Yes, sir.
Can you see what I have written here?
Yes.
So why you just gave the opposite order, right?
Yes, sir.
Was that by mistake or you understood something wrong?
I understood something wrong.
What did you understand?
The primaries.
Primary is? Primary is? Yes, Amalia. Primary is, you were saying something?
Primary is greater.
Primary is greater, no? But you answered totally different. Why is primary greater? Amalia, can you tell me? Why is primary greater?
Because the hydrogen is attached to the nitrogen.
How many hydrogens are attached?
Hydrogen bonds.
Yeah, that's true. But why is, so secondary will also have hydrogens, no? See, secondary nitrogen, it also has hydrogen. So why is primary greater than secondary?
It has
If
three
you're
hydrogen
speaking,
bonds.
because it has two hydrogen bonded to it. Primary has two hydrogen and secondary has only one hydrogen. Yeah, correct. So the order will be, I hope everyone understands now, A will be greater than B and C will be the least. Okay. Is this clear, guys? Yes or no?
Yes, sir.
Okay. Next is solubility. Next is solubility. The physical properties. Solubility. So we know that since amines, they can form hydrogen bond, they will be soluble in water. They will be soluble in water due to the formation of hydrogen bonds with water. But the solubility will decrease with increase in the molar mass of amines because we have two parts. We have R group and we have NH2 group. We have R group and we have NH2 group. So this NH2 group is the one which is hydrophilic. That means this is the one which is responsible for the formation of bonds. But the R group which is present, it is hydrophobic. That means it is not responsible for the bond formation. So as this increases, increase in number of carbons in amines leads to decrease in solubility. And in general, I can write amines are soluble in water due to formation of hydrogen bond with water. Okay, due to formation of hydrogen bond with water. Right, next. Aromatic amines are not soluble in water, are insoluble in water. They are insoluble in water. Okay. Why? Because amines, aromatic amines, they will have 6 carbon atoms which are attached to NH2 group, right? 6 carbon atoms. That is why they are insoluble. A very large hydrophobic part, a very large hydrophobic part. So these aromatic amines, they will be soluble in which type of solvents? Since they are not soluble in water, that is a polar solvent, they are soluble in non-polar solvents. Aromatic amines are soluble in organic solvents. Organic solvents. So organic solvents such as ether, benzene, etc. So this is about solubility. This part is important. That increase in number of carbon atoms in amines leads to decrease in the solubility. Leads to decrease in the solubility. Now we will start studying the chemical properties of amines. Start studying the chemical properties of amine. And chemical properties, let us look at amine. Let us look at amine.
Sir, can you scroll it up?
You are writing this down? Yes, Abir?
Yes, sir, done.
Okay. Chemical properties. No. We have R group and we have nitrogen, which is having a lone pair electron. And there are hydrogen bonds. They are hydrogens attached to nitrogen. Hydrogens attached to nitrogen. Okay. So there are a few things that I can see here. If I talk about the electrons, where they are present. So let me also write it like this rather. CH2. There will be an R group attached here. There will be an R group attached here. Okay. Now, if I look at the electrons, there is a sigma bond and also there is a lone pair. So we have electrons in two different type of molecular orbital. If you can remember, the lowest energy electrons are the sigma bond electrons, followed by the pi bonded electrons, followed by the lone pair. Then we have the orbital which are empty. So these are the only orbital which can be filled. Either you will have electrons in the sigma bond or the pi bond or the lone pair. Then you have the empty orbitals which are A, that represents the empty orbital, followed by pi star, and then followed by sigma star. Okay, followed by sigma star. So this is the order. So we know that we have electrons in the sigma bond because there are sigma bonds here, and also we have electrons in the lone pair. So obviously we can see that this lone pair electron will be very reactive because it is higher in energy. Can all of you see that? Yes or no? Yes or no, guys?
Yes, sir.
So this lone pair is the reactive part of nitrogen. It is the most reactive part. I can say it is the most reactive part of nitrogen. And whenever we have electron source, so this lone pair will be donating its electron to somewhere, and that is why it can act as a Lewis base. It can act as a Lewis base. The first thing is that we will try to understand the basic character of amine. The first property will be chemical property. It will be the basic character of amines. Basic character of amines. Okay. So since it is basic in nature, it can show a reaction with water. If I have R NH2 and I add amines to water, then I am going to get R. This nitrogen, it will attach on one of the water molecules and it will form R NH3 because it will abstract a proton since it is acting as a base. NH3 positive, and there will be OH negative. There will be OH negative. So this is known as alkyne. So for example, if here it is methyl, so it will be methyl ammonium. Ammonium for NH3 positive, and for OH it will be hydroxide. Alkyl ammonium hydroxide. So you can see that it is increasing the amount of OH negative in the solution, and hence it is acting as a base. Hence it is acting as a base. Okay. So you can also have, see, if you have NH3 also plus H2O, it also shows a similar reaction in which you form NH4 positive, OH negative. If you have RNH2 plus H2O, then also it is going to form the same thing. That you will get RNH3 positive charge on nitrogen, and OH negative. So you can see all of these. You can also have R and hydrogen 2 degree amine plus H2O. It is going to give you R and R, and there will be 2 hydrogens of positive charge and OH negative. Even if you have a 3 degree amine, R and R plus H2O, then too you are going to get R3 nitrogen. There will be hydrogen from the water molecule abstracted by the base, that is nitrogen plus, and you will be having OH negative. So even if you have 1 degree, if you have ammonia or 1 degree amine, 2 degree amine, or 3 degree amine, in all of the cases we are increasing the presence of hydroxide ions, right? And that is why these are basic in nature. Amines increase the amount of hydroxide in water, hence they are basic in nature. Hence they are basic in nature. Okay, I hope this is clear with everyone. Yes or no? Yes or no, guys?
Yes, sir.
Okay. Next is we will look at the differences in the basic nature, differences in the basic strength, while we change the groups that are attached to nitrogen, as we did with carboxylic acid, and also we did this carboxylic acid. In that we compared the acidity, and here you will be determining, here will be looking at the basicity.
Sir, can you scroll little up?
Yeah, sure. I'm going to give you the PDF, Abir, by the way.
Okay, sir.
So the topic will be factors affecting basicity. Okay, so now you guys, you will tell me. Well, I will compare 2 things. First of all, aliphatic amines and ammonia. Okay, so we have R nitrogen, which is bonded to hydrogen and hydrogen with lone pairs, versus a nitrogen which is bonded to only hydrogens. Okay, now first thing, this basic character is due to which part? This basic character is due to this lone pair, yes or no?
Yes, sir.
The first thing is that you have to understand, and just you have to remember it, that basic character is directly proportional to the electron density on nitrogen. electron density on nitrogen. Now we have to just compare the electron density at nitrogen. That means whenever we are going to compare electron density, there are few things that should come in your mind: inductive effect, resonance, hyperconjugation. So can you see any resonance here? Can you see any resonance in aliphatic amines? No guys, ऐसा नहीं चलेगा काम आप लोग को. अगर if you can't say in a fraction of second, if you can see resonance yes or no also, that means either you're just not answering in the class, or you don't know. And I hope it is the former rather than the latter. I hope you know this and you're just not answering. So my suggestion is, please start talking. Is there any resonance, guys? Is there any resonance? I just heard some noise, not any answer. Can you please try again? Is there any resonance here? Is there any resonance here? I got your answer. Fatima, Nazira, Amalia, guys. Is there any resonance? Say, I don't know. At least say something, no? Yes, Fatima, you tell me. Is there any resonance here? You guys can't speak or what? Amalia? Amalia, is there any resonance? Okay. Can you guys answer what happened? Nazira, Amalia, Fatima. Is there any resonance here? Methylamine. Fatima, can you please talk? Amalia, anyone? Guys, why are you not answering?
Yes, sir, there is.
Start studying, Amalia. You guys are not studying. How will you, like, I don't know what your plan is, guys. Why you guys are not studying? Amalia, can you please turn the mic on? Yes, Amalia, can you please turn the mic on?
Yes, sir.
Do you know that we have studied resonance before alkyl halides? We did, na, Ahmed? Before alkyl halides?
Yes, sir.
Okay. Amalia, do you have notes of organic chemistry?
Yes, I do.
Sorry?
Yes. Yes.
Yes, you have
I
notes.
do.
Okay. Right now?
Yes, sir.
Okay. So can you please open that? Before alkyl halides, what did we study? Before alkyl halides? Yes, Amelia, did you get anything?
Sir, I don't have the notes.
You don't have the notes. Okay, fine. So you just have to, you can't have the answers. You just have to take whatever I am saying. Otherwise, you would have been able to answer this by your own logic. Now, increasing electron density, R is a plus I group. So that is why it is going to give electron density towards nitrogen. So there will be more electron density in the nitrogen, and hence we can say R group has plus I effect. Hence, it will increase the electron density at nitrogen, which will make it to make easier, which will make, rather I should say, which will make the lone pair more available, which will make the lone pair more available for donation. That is why what we can say, RNH2 has greater basic character than simple ammonia. Now let us compare the basic strength of primary, secondary, and tertiary amine. Now I hope you know the answer, since as the R group will start to increase, the number of R groups on nitrogen atom will start to increase, the basic character will also increase. Comparison between 1 degree, 2 degree, and 3 degree amines. Okay, so since you can say R, nitrogen, R, and R will have higher basic strength than R nitrogen bonded with hydrogen and one more R group. And if you have R nitrogen and 2 hydrogens, why? Because R group, that means alkyl group, has plus I effect, and basic strength directly proportional to number of plus I groups. Number of groups that is going to give the electron density. Okay, is this clear? Yes or no?
Yes, sir.
Okay. Now, write one more point, that the above is true in gas phase when they are in gas phase, but when they are in aqueous state, then we have seen that the tertiary amine, it is very less basic. It is very less basic than the others. But in aqueous phase, tertiary amine is less basic. Now, the reason is what will be the reason here? The reason is that when you have R group that is attached with nitrogen, and if there are many R groups that is attached with nitrogen, then the lone pair, it becomes like very small and it is sterically hindered. So this is completely sterically hindered, and this nitrogen is not able to donate anywhere. So it is available for donation. But there are many barriers. So there is steric hindrance present in the tertiary amines. That is the reason why tertiary amine cannot donate the electrons. So it is available, that is true, but it is not able to donate it. It is not able to donate it due to another reason, that is of steric hindrance. Okay. So if I talk about the order, then the order for, let us take two examples. of methylamines and ethylamines. So if you have CH3, CH2, NH2, and if you have, let us say, let us take methylamine first, CH3NH2, and if you have CH3 whole twice NH, if you have CH3 whole thrice nitrogen. So A, B, and C. So this is what? This is 1 degree, this is 2 degree, and this is 3 degree. So in this case, the 3 degree has been found to be the least, 2 degree is the most. So you have B as the highest boiling. Secondly, you have A, 1 degree, and at last you have C. The reason is steric hindrance. But if I look at ethylamines, in ethylamines we have C2H5 whole twice NH to be the highest. This is followed by C2H5 whole thrice nitrogen, which is followed by C2H5 nitrogen. So this is 2 degree, 3 degree, and 1 degree. Okay, 2 degree, 3 degree, and 1 degree. This is for ethylamine. This is for ethylamine. So you will not be asked directly. If you are asked about the basic character of amines, and they have given you a comparison between 1 degree, 2 degree, and 3 degree. So there will be only these two questions that will be given to you, 1 and 2. Okay, none other question will be given to you guys, because whatever the order is, you cannot predict the order just by the inductive effect on the steric hindrance. It depends on various factors. Okay, see here you have 2 degree, here and then you have 3 degree here, right? In this case, you have 2 degree highest, followed by 1 degree, then you have the 3 degree. But in this case, you have 2 degree highest, then you have 3 degree and 1 degree. So 2 degree will be highest, that is for sure, but we can't say exactly about the 3 degree and 1 degree just by looking at the structure. You have to check the basicity. You have to check the basicity experimentally. Okay. Now, is this clear? Yes or no? Still here?
Yes, sir.
Okay. Now let us compare the basic strength of. But please remember, in gas phase, if they ask in gas phase, then you have to say 3 degree amine will have the highest, followed by 2 degree amine, followed by 1 degree amine, and then followed by ammonia. Okay. In gas phase, it is going to be this order. Now let us compare comparison between aryl amines and aliphatic amines. This is third comparison between aryl amines and aliphatic amines. Okay, so in aryl amines and aliphatic amines, the aryl amines nitrogen, let us look at the aryl amines nitrogen. Here we have nitrogen and H2. There is a lone pair here versus RNH2. Now, as you can see here, there is A double bond B, single bond C, and C has a lone pair. A double bond B, single bond C, and C has a lone pair. So this lone pair will be in resonance, right? This lone pair will be in resonance. Now, since this lone pair is in resonance, it is not available for the donation, and it cannot act as a base. Okay, it cannot act as a good base. Aryl amines will not act as a good base, right? Since the lone pair of NH2 in aryl amines is delocalized. That means it is revolving in the ring. It is not available. It is not localized. In aryl amines is delocalized. Hence, it is not available for donation. Okay, and that is why RNH2 will have higher basic strength than AR that is bonded to NH2. AR means benzene ring or any benzene derivatives, arylamine. Is this clear? Yes or no? Please tell me.
Yes.
Yes. Okay. Now, so we can say that arylamines, these are what? These are not very much basic. So we can have, yeah, this is pretty much it about the basicity of arylamines. Okay, I can give you some questions. You have to arrange them in the decreasing order of their basic strength. So here we have C6H5NH2, C2H5NH2, C2H5 fold twice NH, and here we have NH3. So obviously we can see that C6H5 will be having the lowest, right? Because it is arylamine, the nitrogen's lone pair is not available. Okay, so we have C6H5 at the lowest. Let me just give them a name: A, B, C, and D. Right. So A will be the lowest. This will be followed by obviously D, right? Because both of them are having R group attached to it. So this will be D. Now, when I compare 2-degree amine and 1-degree amine, then 1-degree amine will have lower value in the basic strength. Why? Because it has only one R group attached, and 2-degree amine has two R groups attached. So this will be followed by B, and B will be followed by C. So C is what? 2-degree, having highest, followed by 1-degree. Then you have NH3, that is ammonia, and then you have aryl amine, ARNH2. Please write this question.
Sir, how D is greater than A?
D is greater than A.
Yes, sir. So these
Got
are
it?
in this.
Huh?
So these are in which phase? Gas or liquid phase?
No. If they have not told you anything, that means these will be in your aqueous phase only. Because we generally don't compare in gas phase. It will be in aqueous phase only. See, can you see that they have not mentioned about 3-degree amines only, right?
Yes, sir.
They could have mentioned 3-degree, but they know that we cannot predict. I mean, you have to either memorize it, right? So they don't want you to memorize it. They have given you 2-degree, and 2-degree is going to be greater than 1-degree. That is for sure. That is for sure. Whether it is in gas phase or aqueous phase, and whether it has how many, doesn't matter how many number of carbon atoms it is attached with. You understand about DNA? Yes or no? Tell me.
So this is ammonia. Yes, I understood. Yeah.
Understood, no? Because this lone pair here, it is delocalized. ये है ही नहीं यहाँ पे, है ना? It is not present.
Yes, sir.
Write this down. Let me know if you're done.
Yes. Done.
Done? Okay. Another question that you can get from here is, why are aryl amines less basic? Okay, why are aryl amines less basic? So there are multitude of reasons that you can write. Number one, the answer. Number one reason you can write is due to delocalization. The lone pair is unavailable. Then if it is 1 mark question, 2 mark question, okay, if it is even if it is 1 mark and if you have time, then you will draw the resonating structures for amine. Okay, you will have nitrogen NH2, NH2 positive, and you'll have a negative sign here. These bonds will be intact. Further again, this will move here, and you are going to get NH2 with a double bond here, a negative charge here, a positive sign in the nitrogen. Right. So you can draw further more resonating structure, and you can see that nitrogen doesn't even have a lone pair localized. It is what? It is delocalized. So that is one of the reason. Next reason is, like, let us suppose that even if that lone pair was available and they formed a compound, they attacked on hydrogen and they extracted hydrogen. So you have with NH2, let us react this with water, and let us suppose you formed NH3 positive, right? Now this is base. This will be conjugate acid. Now let us talk about the stability of conjugate acid. So the conjugate acid of arylamine is not stabilized. Right? It is not going to stabilize. Why? Because NH3 positive and a double bond, then you have single bonds here. Now, how much, if you want to have a resonating structures like this, that A double bond B with a single bond C and C has a positive charge. So we have this condition that if you have A double bond B, single bond C and C a positive charge, then this bond can go there and you can have resonating structure in which A will have the positive charge, B and C will have a double bond. So if I write a resonating structure such that the nitrogen and carbon, there will be 2 bonds, then it will be violating the octet rule. So I cannot have this resonating structure. Double bond NH3. Now it is not possible. Why? Because nitrogen is making 5 bonds, and nitrogen being in the second period element, it cannot hold 5. It cannot hold 5 bonds, or rather 10 electrons. Right? If I have 5 bonds, that means 10 electrons, and the second orbit can only have how many electrons? 8 electrons. Okay, so we cannot make resonating structure. That is why the conjugate acid of arylamine is not stabilized. It's not stabilized as resonance is not possible. As resonance is not possible. Okay, so these are the 2 reasons that you will write. And please remember to draw the resonating structure. Draw the resonating structure. Okay.
Yes, sir.
So what is going to happen? Acha. Now let us look at another reactions. So the first reaction is this only, that the reaction with water, as you can see. Then you have the comparison between different types of amines and ammonia. And then the next reaction is the alkylation of amines. Next reaction is alkylation. So we got a taste of alkylation just in the preparation also. If you remember, we had R NH2 and it reacted with any of the Rx. Let us say R dash X. Then this nitrogen atom, it attacked on this R dash, X got to leave and you formed R. So there was one hydrogen which also left as soon as it wanted. So first of all, you will form R, which is bonded to nitrogen. This nitrogen will also bond to R. Then you will have hydrogen. Then again one more hydrogen. And here you have X negative. So as you can see, nitrogen will have positive charge. This hydrogen here, these are what? Electron deficient, because it is attached with nitrogen, which is electronegative, and that nitrogen also has a positive charge. Now it is more and more electronegative. So these hydrogens are electron deficient. So X negative will attack on hydrogen. You will abstract a hydrogen and you will be getting R nitrogen and R dash with a hydrogen here, Okay. So if you start with 1 degree amine, you are going to get 2 degree amine if you react this with alkyl halide. So you can write a point that when 1 degree amine reacts with alkyl halide, it forms 2 degree amine, right? It forms 2 degree amine. Similarly, when 2 degree amine reacts with alkyl halide, it forms 3 degree amine. And what happens if we have 3 degree amine? When 3 degree amine reacts with alkyl halide, it forms quaternary ammonium salt. Quaternary ammonium salt. So we have seen this earlier also, right? Let me also give you reactions if you don't remember. कल ही देखा है हम लोगों ने RNH2. If you can start with ammonia also. You have ammonia, you react with any alkyl halide, you react this with RX, you will be getting RNH2. You have RNH2, you react this with R1X, you will be getting RNH R1. R1. Now you have RNH R1, you react this with R2X and you will be getting R N R2 and R1. Now if you have R N R2 and R1, you react this with R3X, then you will be getting R N R2 R1 R3 positive, and there will be X negative. Okay, there will be X negative. I hope this is fine. Yes or no?
Yes, sir.
Yes, right. We have done this. We have done this earlier also. Okay, so this is all about the alkylation. Then you have another reaction which is known as acylation. And in acylation, right next, that is acylation reaction. Acylation. If you have RNH2 and you react this with, let us suppose starting with acyl fluoride, R C double bond O Cl, R C double bond O Cl. Now here you have to see this nitrogen is having a lone pair electron. It's having a lone pair electron. this carbon, this our carbon, which is carbonyl carbon, it is delta positive, yes or no? Because it is attached with oxygen, which is electronegative, chlorine, which is also electronegative, right guys? Yes or no?
Yes, sir.
Now, what is going to happen? It is going to attack on this carbon atom. That means this alkyne, this nitrogen is going to attack on the carbon atom. So let us see. We have R with nitrogen. Nitrogen has attached on the, now as soon as it will attack on the carbon, one of the carbon bonds will break, yes or no? One of the carbon bonds will break, and as you can see, carbon has this sigma bond. This is also sigma bond, and this double bond O, it has one pi bond. So obviously pi bond is more easy to break, so one of the pi bond will break. So now you have carbon attached to it. Now this carbon was attached to oxygen, now which has a single bond. This carbon is also attached to a R group. This carbon is also attached to a Cl group, right? This nitrogen is attached to hydrogen. This nitrogen is also attached to one more hydrogen. Yes or no, guys?
Yes, sir.
Tell me, any problem till here?
No, sir.
No problem, right? No problem. Now what is going to happen? Here we have a positive charge, and here we have a negative charge. Okay. Now, this oxygen, it will slowly, rather, first of all, what happens is that this chlorine and hydrogen, as you can see, they are in vicinity, right? They are in vicinity, and this hydrogen will be obviously very delta positive because it is attached to nitrogen, which is electronegative and also positively charged. So basically, this HCl, they bind together. Now, when HCl is leaving, this oxygen will start forming a bond like this. So oxygen will give the electron density, and it will form CO bond. This chlorine will take the electrons, and the hydrogen will give electrons to nitrogen. Hydrogen will give electrons to nitrogen. So basically what you are going to get is, make some space. You have R, there is NH, then you have carbon, which has R group here, and there is a double bond O. Can you see that? Yes or no? Please tell me.
Yes, sir.
Right? Plus HCl just left, right? Yes or no? HCl just left. Okay. Now, so what are these molecules? These are amides. Yes or no?
Yes,
Can you
sir.
see these are amides? Right. So amide has a very particular bond, that is NH and C double bond O. This is amide. Now, reaction, and important will be the name of these type of amides. How do we write the name? Let us start with CS3 NH2 plus CS3 C double bond O Cl. Now, obviously, this you can also write it like this. That may help you in forming the molecule. You can write the Cl first, carbon double bond O, and then CS3. Now, this hydrogen, there are two hydrogens. So this hydrogen and chlorine, they will get together and they will be eliminated. So you will get CS3, which is bonded to nitrogen. This nitrogen is bonded to hydrogen. This nitrogen will then be further bonded to carbon, C double bond O and CS3. C double bond O and CS3. How will we name this? First of all, identify the functional group. This is going to be amide. Then is the unsaturation. So we see that carbon-carbon single bond only is present. So carbon-carbon single bond, that is by AN. Furthermore, parent. Now, if I want to choose the parent, I have one carbon here, one carbon here. So I can choose any of the carbon. Now, please, I will choose that carbon atom. I will choose that carbon atom, that terminal. We have two terminals, A. Oops. We can choose A or B. But we will choose that one which is directly bonded to the amide. So we remember that CONH2. CON, this is the amide bond. So this carbon atom which is bonded, to oxygen and nitrogen, this is the functional group, and that is why this will be our, this is going to be our parent. So you can see there are two carbon atoms in the parent, that is eth. That is eth. Now, we have already taken care of the amide bond. That means I have taken care of this much part. In the functional group unsaturation and parent, I have taken care of this much more, and we just remain, there is only a CS3 group that is remaining. So this will be in the substituent, this will be methyl. Now the position of methyl will be, it is attached to nitrogen, that is why this will be N-methyl. So we have N-methyl, we have N-methyl ethane amide, N-methyl ethane amide. Okay, N-methyl ethane amide. Now, important point is this methyl, this is coming from the amine. Yes or no? This methyl is coming from the amine. And what about this ethane amide? This eth will be coming from the
Parent chain.
acyl chloride. This acyl chloride, no? We are identifying where are these coming from. From the reactant. ये तो आपने product से बताया ना, parent chain. That is correct. But I am talking about the reactant. This methyl, which is bonded to nitrogen, it is coming from the amine that we have reacted, and this eth, the 2 carbon, it is coming from the acyl chloride that we used in the reactant. Okay. Now it is going to be easy, guys. Okay, it is going to be easy. Let me tell you. If you have CS3 and let us say NH2 plus Cl, C double bond O, CH2, CS3. Okay. If you directly want to predict the product and write the name of the product, you tell me how many carbon atoms are there in the amine? How many carbons?
3.
How many
1.
carbons in the amine?
1.
1 carbon, right? So it will be N-methyl. Now you tell me how many carbon atoms are there in the acyl chloride?
3.
3. That means prop.
Yes.
So propanamide. Okay, you can directly write the name also just by looking at the structure. Just by looking at the structure, don't hesitate too much. Okay, don't hesitate too much. But you have to take in consideration. No, it will be fine only. You will only get this these type of elements only, unless and until you have some branch. Then you will have to exactly make the structure and all. You know? If you have CS3 like this, then you will have to make the structure and all, and you have to also write the CS3 as a substituent. That is if you have any complex things given. Now, if you want to make the product, it will be CS3 NH, carbon double bond O, CH2, CS3. Okay. So please tell me, are you fine with this? Yes or no?
Yes, sir.
Okay. Now, a similar type of reaction is also shown if you react amines with anhydrides. You have CS3, NH2. If you react this with anhydride, that is CS3, C double bond O, O, C double bond O, and CS3. So in this case also what happens, one of the hydrogen, it attaches with this oxygen and it will form carboxylic acid, and this carbon, it will be forming the amide bond. So you will get CS3 N H C double bond O CS3 plus with this carbon atom you will be getting CS3 C double bond O OH. Okay. So this much carbon, it formed the amide, and the rest of them, it attacked on the hydrogen of nitrogen and it formed carboxylic acid. Okay, it formed carboxylic acid. So in these two reactions, you are going to form amide. So formation of amide from amines. Okay. So that's it for today. Let me give you some questions that you can do. So the first one is easy because it is what? Basic strength. Hai na? Now, when you're talking about the basic strength, it will be in aqueous phase only. Okay, whenever we are talking about basic strength, it will be an aqueous phase only. In the second reaction, you just have a base and an acid, base and an acid. Okay, so acid base reaction, you have to do nothing else. So these are the two homeworks. Now, let me share the PDF with you guys.